corporate finance practice problem using OneNote. We're going to be calculating the bond value, bond price, and we'll do so with different yield rates. This is going to be the second problem of a similar nature. Get ready. It's time to take your chance with corporate finance. Here we are in OneNote. If you have access to OneNote and would like to follow along, you're not required to, but if would like to, we're going to be in the icon on the left-hand side. We're in the practice problems down here in the 1012 bond value different yield rates problem number 2 item. Also note that if using OneNote, you might want to take a look at the immersive reader. Many of our presentations also are going to be down here in the text area. The text items having the same number for them and being transcripts that can then be translated into multiple different languages and either listened to or read in those languages, thereby being a good complement to the practice problems. Closing this back out, we're going to have our information up top. We're going to populate that information into the area down below. We will run different scenarios, multiple different scenarios using different market rates. So our baseline starting scenario, we're going to have the bonds outstanding. Par value is going to be the 1,000. The percent is going to be the 18%. We're going to imagine this being the information we could get if we actually had like the bond in front of us, what we can get from the face of the bond, that being the par value, the percent, the 18%. We can imagine that on the bond. And then the maturity date, which we're going to say is in 20 years. We compare that then to the market information, such as the market rate or the yield that the market would expect. And then that difference can then help us to figure out what the price would be. So note that when thinking about the price, which is what we will then focus in on here, normally when you issue the bond, if I was to issue the bond, I would try to pick a rate that would be the market rate. So if I issue the bond, then I would think that the rate 18% matching the market rate. If that were the case, we could then issue the bonds for the face amount of the bonds, or the par value, in this case, the $1,000. However, if that's not the case, or if time passes, then it's likely that it will not be the case, where the rate on the bond will match the market rates at that point in time, or any future point in time. You'll have a difference. You can't change the rate on the bond because that's going to be already on the bond. What you can then change is the price that you would sell for. So the basic scenario, note, if you just issued the bond and you had the same rate as the market rate, then you would issue it for the amount of the bond and everything would be good. However, if it's different, then you run your kind of question scenario. If I'm the issuer of the bond, I'm trying to get money by issuing the bond, then if the rate on the bond was 18% that we're going to be paying to someone else who buys the bond, and the market rate was below that, say 11%, we as the issuer, we could think of have the advantage. We would be out on the market saying, hey, look, you're not going to find another bond like our bond and be getting 18% on it. You know, the market's only like at 11%. So we would then assume that we would be selling it at an advantage at a premium for more than the face amount of the bond. We will then sell it for more. If, on the other hand, we're going out to the market and saying, yeah, that's a pretty high rate, 18%, but the market's saying, hey, I can get 20% elsewhere. So in that situation, we'd have to say, if that were the case, if we want to sell our bond, we can't change the rate. We would have to lower then the price of the bond, and we would sell it then at a discount. That's the basic scenario. Then the question, of course, is, well, how much should the amount of the price of the bond be? So once we know that it's either going to be the same as the face, higher or lower, what will the actual amounts be? We'll do that with our calculations down below, starting with the yield or market rate of the 11%, 10%, 20%, remembering that these are percents that are perceived by the market. We'd have to determine what those rates are basically under the market conditions. This information we can assume would basically be on the bond, we're saying. So we have our calculation. We'll have to do two components here when we think about present valuing something. The bond's going to have a series of payments, which will be the face amount times the percent. In this case, they're going to be yearly payments, and there'll be 20 of them. That's an annuity. So we can present value the annuity and then add to it the present value of 1, the principal, at the end of the time frame, back to the current period. Adding those two things together will then give us what we would expect to be a reasonable market price. So let's do that first with the market rate at the 11%. We're going to present value the annuity, a series of payments, that being the 1,000 times the 18%, the rate on the bond. Present value of an annuity formula is P times 1 minus 1 plus R to the negative N over R. P would be the 1,000 times 18%, the payments that would be happening, in our case, yearly, times 1 minus 1 plus R. R then is going to be the market rate, 11% in our example, to the negative n, number of periods, in our case yearly, 20 periods, over R, which again, market rate 11%. Let's break this out into our table type of format down below. We're going to have the 180, that's going to be then the 1,000 times the 18%, 0.18, that's going to be our 180. We're then going to pull the numerator into the inside. We're going to have 1 and then pull in that 1 plus R to the negative n, 1 plus R, 11% market rate this time, not the rate on the bond, 100% plus 11%, or 1 plus 1.11 gives us 111%, or 1.11 to the negative n, number of periods, in our case 20, because the rates are going to be paid annually, gives us this number. I'll calculate it this time with the calculator, noting that we do need a calculator that can handle this caret, or taken to the power of 20. In our case, I'll pick up the scientific calculator, doing the calculation as 1 plus 11%, 0.011, I'm sorry, 0.11, and that's going to give us 1.11, or 111% to the power of, which is going to be x to the y. That gives us the caret 20, and then I need to make that negative, so I'm going to make it a negative like so, and there we have it. There's the 0.124033. Make sure that if you are using a calculator on a test, that you understand that, you know, how to use the functions on that particular calculator. If you're practicing with Excel or whatnot, make sure that you can transpose the information to the circumstances that you'll be needing them for in like a testing situation. So then if we subtract this out, we're going to say something like 1 minus the 0.124033907 would give us the 0.875966093. That's going to be the numerator. So there's the numerator. The denom, or denominator, is going to be the 11%. So the num divided by the denom. So divided by the denom, 0.11 is going to give us about, if I make this larger here, it doesn't handle that long, 7.96332, and so on. And then if I multiply that times p, finally, 180, that's going to give us the 1433.4 about. So that's going to be the present value of then the annuity portion. We're going to have to add to that the present value of 1, which is going to be the 1,000 at the end of the time period, the 20 periods. But before we do, let's do this first calculation a few different ways. We can break out the annuity 20 payments down to the single payments, or 20 single payments. Let's see what that would look like, because that'll be fun. We've got period 1, 180. 180 is the 1,000 times the amount that would be on the bond, because that's how much we would get paid, 180 per period, in this case year. Present valuing that one payment would be 162 if we present value it at the 11%. I won't show the calculation for the present value here. We can assume that we do it in Excel. I highly recommend practicing this in Excel, where we do focus in on more on the calculations in Excel. And that would give us the 162. If we did that for period 2, we'd say the second payment that we get, because it's an annuity, and that means we get like equal payments, 180. If I present value that back to the first period, that would be 146 back to period 0. And then if I add that 146 to the prior present valued amount for period 1, 162, we get the 308. Continuing this process, period 3, we get paid another 180, or there'd be another payment on the annuity. And then we present value that 3 periods back. That would be 132 present valued at 11%. 132 plus 308 would give us the 440. So for 440, if we did that process all the way down for the 20 payments, difficult to do this way, easy to do in Excel, we'd get to that 1433, this time not rounded. We don't have the pennies, we don't have the cents involved, but we get to that same value of the annuity. Also note that you might say, hey, look, I can just tack on in this method. If I'm just present valuing ones here, we could then present value the thing we would get at the end, the 1,000, 20 periods out. If I present value that at the 124 and add that to the prior amount, the 1433, we would get the 1557, that in essence being the price that we would expect, that then basically being the answer, the market price that we might consider selling or purchasing the item at. And that price is higher than the par value here, the 1,000, due to the fact that the interest rate on the bond is much higher, 18%, than the market rate being the 11%. So we'll get to this answer again. I know this way is really a good way to do because it kind of breaks out the payments, but it's not the typical way we would see in a test question or the shortest way to get there, the most direct way. So let's do it again. Let's calculate this calculation again, the 1044, the annuity portion. We could do that with an Excel formula or a financial calculator, which is probably the fastest way to do it. And I would think Excel might even be more common soon, considering you can use a spreadsheet on your phone now and whatnot. And that would be the rate would be the 11%, comma, number of periods would be 20, comma, and then the payment would be then the amount of the 1,000 times the 18 or the 180. That then giving us the 1433.4 again. We can also do it, of course, with the tables, 180, 1,000 times 18, picking up the table amount, making sure we got the right table, present value of an annuity, 11%, 20 periods. So we have the 11%, 20 periods, 7.9633. So 7.9633 times 180 gives us 33.39, close to, not exact. This amount up top, off by a penny due to rounding, tables rounding then to 4 digits. So be careful of the rounding. Probably not a significant difference, of course, for decision-making purposes, but test questions might utilize that to force you to use one method or another. Now, let's think about the present value of the 1,000, the principal at the end of that 20 periods. We'd be using this formula. Present value equals future value over, we can think of it over, 1 plus r to the n. Future value, 1,000 this time, over 1 plus r, 11% market rate to the number of periods, in this case years, 20. Putting that into a table type of format, 1,000, there is the 1,000. For the future value, the num or numerator, 1 plus r, so 1 plus r, 11%, so 100% plus 11%, or 1 plus 0.11 gives us the 111% or 1.11. Taking that to the power of 20, the number of periods would give us about 8.06231115. Then we could take the num divided by the denom, 1,000 divided by the 8.06231115, giving us the result of 124.03. That being the value of the 1,000 at the end of the 20 periods. If we add that then to the amount we got last time, the annuity, the 1433.4, we get to that 1557.43. That then the value or the price that we would expect, it then being higher than the face amount, due to the fact that the interest rate on the bond is higher than the market rate. This amount down here, the 1557.43, matches what we got up top in this yellow area up top, 1557, although no pennies are here, this is a rounded number. So there we have that. Now we can calculate this a few different ways. Let's get to this number a few different ways. The fastest way would be to use an Excel function. Excel function being the present value of the rate, 11% market rate, not the rate on the bond, comma, then the number of periods, 20 periods, comma, comma, and then the future value, looking future value, that then being the 1,000 to give us the 124.03. We can also do it with the tables. Tables making sure we got the proper table, this time being the present value of 1, not present value of an annuity. That would be then 11% and 20. 11 and 20, there's 11, there's 20.1240, so 1,000 times 0.1420 gives us 124 again. So there's going to be the first one. Let's compare that then to an 11%. Similar, but a little bit different. 10% this time. The rate's a little bit different now. It's still far below, of course, the rate on the bond. So same kind of scenario in that if we were the person issuing the bond, we would have the advantage there. We would be saying, hey, look, you're not going to get 18% return. So we'll sell you our bond at something greater than the 1,000, most likely. That's going to be our scenario. So then we got to figure out how much greater. So we'll do our present value calculations to do that. And then the last one will be a situation where the market price, 20, will be higher than what we have on the face of the bond, and therefore resulting in us having to sell at that time at a discount, a price less than the 1,000 in our case. So now we're looking 10%. We know that we expect the result to be higher than the 1,000. How much higher? Got to do the calculations to do that. So we're going to present value the annuity, which is a series of payments for 20 periods, which will be the 18 times 1,000, but now present valuing them at the 10% rather than the 11% using our formula. P times 1 minus 1 plus r to the negative n over r. P is going to be, once again, the 1,000 times the 18, or 180, times 1 minus 1 plus r. Now r is the market rate of 10% as opposed to the 11 it was last time, to the negative n, still 20, over r, which once again is 10% as opposed to 11 last time. Putting that into our table, we got the 180. That's 1,000 times 18%, 180. Then we'll take the numerator, 1, pulling that into its own column. Then 1 plus r to the negative n, I'm pulling that into the inner column, 1. R, now 10%, that's the thing that has changed. That 100 plus 10, or 1 plus 0.1, gives us 1.1, or 110%, to the power of the number of periods, in this case years, of 20. So 110%, or 1.11 to the 20, caret 20, to the power of negative 20, I should say, because that would be the right thing to say. And that would be 0.148643363. Then I'm going to take the 1 minus that amount we just got to, finishing up the numerator. 0.85135,637, that's the numerator. The denominator then is r, or 10%. The num divided by the denom is going to give us that 8.51356372. And then we can take the p times that number, or the 180 times that 8.513. That'll give us the 1532.44, that being the current value of the annuity portion. We need to add that to the present value of the 1,000, the principal at the end of the payment, in order to get to what we would assume to be a reasonable price, the proper price. Before we do so, let's do this calculation a few different ways. We're going to break this annuity down into a series of present value of 1 payments. So we have 20 payments of 180. Let's just present value all of them back to the current period and use this format. So I can say period 1, we're going to have an annuity payment of 180. Present valuing it, assuming to do it like in Excel. So I won't do the calculation, we'll see it later. But we can use Excel. Highly recommend looking at this problem in Excel, where we will go over these calculations in this format. That would give us the 164. If I took the second payment of 180 and then present valued it at the 10% this time, we would get to the 149. The 149 plus the prior payment that we present valued at 164 would give us the 312. The third payment then, 180, present valued 3 periods back at the 10%, is 135. 135 plus the prior balance of 312 would give us the 448. Doing this process all the way down would get us once again to that 1532 without the cents added, no pennies this time. So that matches what we got up top. Then we could say, hey, look, I could just tack on the last payment, which is the 1,000 payment of 1, bringing it back also 20 periods, because it's going to be 20 periods out. The 1,000 present valued back 20 periods would be the 149. The 149 plus the 1532 would give us the 1681. That 1681 would in essence be the price. That in essence is the answer. That answer higher than, the price being higher than the par value or face amount of the bond, due to the fact that the bond is paying 18%, whereas the market is only having similar items at the 10%. Therefore, if we issued the bond, you would think we would be able to issue it at a higher price in that case. We're going to get to this number again. Before we do, let's calculate this 1532, the amount of the annuity, a few more ways. The easiest way to get there, the magical way, would be the way with the Excel function. So we would use Excel function present value of the rate. The rate's going to be then, we're looking at the 10% this time. Number of periods, which are going to be 20. That would be 20. And then the payment amount, which would be the 1,000 times the 18, which would be the rate on the bond, which would be the 180. That gives us the 1532.44. We can also calculate with the tables, 1,000 times the table amount, which is going to, the 1,000 times 18, or 180, the amount of the payment for the annuity, times the table amount, which would be 10% is what we're looking for, 20 periods, making sure we got the proper table, the annuity table, present value of an annuity. So 10%, 20. 10, and 20 is the 8.5136. So 180 times 8.5136 gives us the 1532.45. So then we can calculate, now we're going to do the second component here, which is the calculation of the present value of the $1,000. Formula is going to be the present value equals the future value. We could think about it as over, basically. 1 plus r to the n, future value, the 1,000. And then we got the 1 plus r, now 10% to n, number of periods, which is going to be 20. Putting that into our table type of format, we're going to say the numerator, 1,000. And then we're picking up the denominator, 1 plus r, 10% this time. 100% plus 10%, or 1 plus 0.1 gives us 1.1, or 110% to the power of the number of periods, which is going to be 20. That then giving us the 6.72749999 about. If we take the num, 1,000 divided by the denom of the 6.727499 and so on, that then gives us the 148.64. So that's going to be the value of that one payment at the end. If I add that to what we got with the annuity portion, the 153244 plus the 148.64, that gives us our end result, the 1681.09, that being the value or the price of the bond that we would expect to get, it being again higher than the face amount due to the rate of the bond being much higher than the market rate. That amount of the 1681.09 we also got to back up top in this yellow area, the 1681 about, because we don't have the pennies involved here, but that's another method you can get to that answer. Now let's recalculate this one a few different times. The fastest way would be the Excel formula, most likely, which would be the present value of the rate, 10%, comma, number of periods, 20, and then we say comma, comma, because it's not an annuity, but present value of 1, present value being the 1,000 times the 18%, or 180, would give us then that 148.64 again. We can get to that number another way using the tables, making sure we got the proper table, that being not an annuity table this time, but present value of 1 table, and that would then looking at the rate, which would be the 10% and 20, 10 and 20, 10, 20. So we got the 10 and then the 20 would be the 0.1486. So 1,000 times 0.1486 would be the 148.6. So that's another way we can get to that portion of the present value of 1. Okay, so now let's look at it this time using the 20%. The 20% now, the market rate, higher than the rate that we're assuming that would be on the bond. And therefore, if we run our scenario, we're trying to issue a bond, we're trying to get money, we're trying to raise capital, we're trying to issue it, and the market's saying, well, 18 seems pretty high normally, but we can get 20 out on similar bonds out there. And if we can't sell our bond, we're going to have to say, okay, well then we're going to lower the price. I can't change the 18, we'll lower the price of the bond, so we're going to have to sell it at a discount then. And then the question is, well, how much less? So we expect the answer to be less than 1,000. How much less? Got to do the present value calculations, present value of the annuity, present value of 1. Let's do it. So we have the present value of the annuity. P times 1 minus 1 plus r to the negative n over r. P is going to be, once again, 1,000 times 18%, or 180, times 1 minus 1 plus r, this time r 20%, to the negative n, still 20, like it was last time, over r, once again, this time 20%. Let's put that into our table. We got the 180, which is going to be the 1,000 times the 18%, times the numerator, 1 minus 1 plus r, there's the 1. Then we're looking at that 1 plus r to the negative n, there's the 1, r, 20%. 100% plus 20%, or 1 plus the 0.2 would be 1.2, or 120. Then to the power of 20, which this time is this 20, the number of years, to the negative power of 20. That would be the 0.0260841. Then we're going to take this 1 minus that number, ending off with the num or numerator at 0.9739159. The denominator then at the 20%, 20% for r. The num divided by the denom gives us the 4.8695797. Then p times that number, 180 times the 4.86957 gives us the 876.52, that being the value of the annuity, which we would then have to value to the present value of 1, the 1,000 principal, to get to what we would think would be the appropriate price. So let's recalculate this one, however, a couple different ways before we do the second component. We'll recalculate the annuity, the 20 payments, as 20 present value of 1 payments in this way. We're going to say the first payment was 180. That's 1,000 times 18. That gives us 180. If we were to present value it, assuming we just use Excel to do the quick present value of that one payment, it would be worth a present value at the 20% of 150. If we then take a look at the second payment, 180, present value it 2 periods back at the rate of the 120, the market rate, we would be at the 125. That 125 plus the 150 would give us the current present value after 2 payments of the annuity, the 275. If we take the third payment of the 180, we present value it back to the current period using the market rate, 20%, giving us the 104. That 104 plus the 275 would then give us the balance of the 379. If we continue that process on down for 20 periods, we would then be at the 877. No cents, no pennies rounded, that 877 matching out then to that 876.52, which has the periods up top. We also can then add on that last payment, which would be the $1,000 for the ending balance. That $1,000 ending balance, we can bring it all the way back 20 periods in a similar fashion. Periods 20 again, bringing that 1,000 back 20 periods would be $26. The 877 plus the 26 would be the 903, that in essence being the answer, that in essence being the price, that price being less than the $1,000 face amount due to the fact that the market rate now is higher than the rate on the bond. People on the market are saying, I can go elsewhere, get a better deal. You need to lower the price. You need a discount in order for me to purchase that item there. So that's what we would expect. We'll get to that number again later. But first, let's recalculate this 877 a couple different ways. The first way being the easy way, this with an Excel function. Present value times the rate, which would be 20, number of periods, which would then be 20 again, and then comma, the payment would then be the 1,000 times the 18, or 180, giving us that 876.52, this being, again, the annuity proportion of the calculation. We can get that annuity portion using tables too, making sure we get the proper table, this being an annuity table, as opposed to the present value of 1. It's going to then be at the rate of 20% and 20. We're looking 20%, 20 periods, 2020. Just like I wish my vision was 2020. So there's the 20, and then 20 is down here, 4.8696. I think vision, you can actually get better than 2020. I always thought that was like the best because it's normal, but I would like, anyway. So the 180 times the 4.8696 would give us that 876.53 also. It's close to, might not be exact up here, it's off by a penny due to the tables being rounded to 4 digits. Then let's calculate the present value of 1, that 1,000, bringing it all the way back to the current period again, using that 20%, that 20% this time. Present value of 1 calculation is present value times the future value. You can think of it as over 1 plus r to the n. Present value equals future value, 1,000 this time, over 1 plus r, now 20, to the number of periods, still 20. So let's do that with our calculation. 1,000 is the num, or numerator. 1 plus r to the n, there's 1, there's r, 20%. That's 100 plus 20, or 120, or 1 plus 0.2, 1.2, giving us 120 to the power of n, caret n, number of periods, 20 years. That then gives us the 38.3376. If we take the num divided by the denom, we get the 26.08. Adding that 26.08, the current present value of that 1,000 payment that's 20 years later, to the 876.52, the annuity payment, we get to the 902.61. That being the value of the bond being less than the 1,000 face amount due to the fact that the interest rate on the market is higher than the interest rate of the bond, the 18%. That 902.61 also being the number we found up top in this yellow number, the 903, when we just did the running balance calculation. That's another way that you can get to the answer. So let's now recalculate this 2608 a few different ways. Next way, the easy way, that being Excel, which we use the present value of the rate, this time market rate 20, comma, the number of periods 20, that stayed the same, comma, comma, because it's not an annuity, but present value of 1, future value payment, the 1,000 times 18 or the 180, also giving us that 26.08. We can also do it once again with the tables, rounding it out with the table time, making sure that we got the proper table, not present value of an annuity, present value of 1, this time looking at the 20%, 20 years. 2020 once again, but with a different table. 2020, different table. This is the one with the smaller numbers. You know, like, I can't say it, my eyes aren't 2020. Anyway, 0.0261, 0.0261. So there it is, 1,000 times the 0.0261 is going to give us the 26.10. That number's slightly different than the 2608 due to the tables rounded to 4 digits.